In this problem, we're supposed to complete this table for the population growth model for a certain country. We're told the population in 2003. We're supposed to project the population in the year 2040, and we're given a growth rate to use. So one thing we've got here, if we're starting with the population in 2003, we're going to think of that as t equals 0. So t equals 0 is going to be the year 2003. If I want to go then to the year 2040, well, that's a 37-year difference if I subtract those. So I'm going to be looking for what's happening when t is 37. We can start with the general population growth model, exponential growth and decay model. A equals a sub 0 times e to the kt power. We want to keep track of that. That's that general growth and decay model. And what we've got here, this of course is going to be my value a sub 0. That's my starting value in 2003. This projected value in the future is going to be a, and of course what we've got here is k. The other thing that we're going to be using here is that the value t is going to be 37. So I'm going to plug in that information. I don't know a sub 0 is going to be 48.5. We've got E. My K value is 0.0194. And my T value is 37. So this problem, once I write it out like this, I realize, well, this really isn't that tough at all. This is just a calculation. I don't have to solve for anything, right? A is already by itself. That's what I'm looking for. So I'm just going to have to evaluate this on a calculator. The directions here don't say how far to round. I'll just choose something at the end. You'll want to pay attention. Often this is going to tell you how many decimal places to round to, and you just want to follow those rules if that comes out. So as is the case here, most calculators these days, we hit the e to the x button before we put in the exponent. So most calculators we can enter exactly how this is. We would just do 48.5 times. We need to do the e to the x button on the calculator. Usually to do e to the x, we have to hit second and natural log. Okay? And that's going to open a set of parentheses on most calculators. If it doesn't, you're going to want to probably open that set of parentheses yourself. Then I'm going to do 0.0194 times 37, and then I can close the parentheses and hit enter. So it pretty much just goes in the way it looks. Some calculators, we have to put in the exponent before I do the e to the x button. And so if you have a calculator like that, you're going to start with the exponent, 0.0194 times 37, and then you'll hit equals. That forces the calculator to figure out that exponent. Then I'll take e to that power by hitting the second ln button. Notice that immediately does e to the x. That's now what's in my display. So what's in your display on the calculator at this point is this stuff. You still don't have the 48.5, so I can multiply it by that at the end, times 48.5 equals. Okay, so you'll do one of those calculations depending on your calculator. If I do that, I get my value of A is approximately 99.421 ... It keeps going forever. I'm just going to go ahead and round to the nearest tenth. So I'll look at the 4. The next digit is a 2. That means I'm going to round down. So I'm going to say A is approximately 99.4.